So the way that we do these sketches, these are big sketches. The first one is going to take us half an hour or more. Now that's because I'm going to do a lot of explaining, but these are long questions. They have a lot of different parts. And you do all this kind of pre-work and prep work, all these different things, and you get all these properties written out, and some of it is that asymptote testing that we did in the last lesson, right? And then you have to take all of that and actually put it into a sketch, and so that's what we're doing. Notice the instructions, what they say, and they will always say this, even if for whatever reason they don't say it. It's implied, okay? You have to fully label your sketch, and by that we mean you have to find all the intercepts and show them and label them, find all the asymptotes, obviously draw them in and label them, and find the end behaviors. We'll pencil those in, and then we'll just use them to draw the function. Okay, and that's what we'll always do for all of these kinds of sketches. Okay, so the pre-work is finding all of that, and then we'll put it together in a sketch. As I said, these are long questions, and there's a lot of parts to them. And if your work is unorganized, it's harder to mark, but it's also going to be harder for you to follow. Okay? So I'm going to recommend that however you do it, you try to do it the same way every single time. I even organize bits and pieces on my paper in the same way. That's just my habit. And I've told you this before. Habits really help take load off of your brain to think about more important things. And when you go to put all the pieces together to draw the graph, if you know where to find everything that you need, it'll just be a lot easier and a lot faster. So it's efficient, but you're less likely to make little mistakes or lose track of something or misread something. Okay? So you could follow my method exactly in the order that I do things, but obviously, or you could make up your own. But whatever you do, it's something you need to think about. The other thing you do need to think about is like your work does have to be organized in a way that it can be read when it's being marked. Okay, so it can't try not to just have it be random all over the place. Try to, as you're practicing, and think a little bit about where you're organizing it on the page. And some people that comes naturally, and some people it really doesn't. I know, but it might be worth spending a little bit of time thinking about that. The first thing that I like to do when I start a new question. Anybody have an idea? We kind of talked about this before. We're going to factor it. So when you get to calculus, if you're taking calculus, there's more versions of the function that we can calculate to get more information, and the sketches become even bigger. And so that's what you would start with. You would factor, but also do some other things that are calculus things. And that's the same way. When I'm doing those, I do it the same way. So, if you have me for calculus, I'll say the exact same thing. Okay, we're going to factor, and we're going to get all the different versions of the different functions that we're going to be using to sketch all first. Get that out of the way, and then move on to the properties. That's how I do it. So this one is actually a little bit different. The next one will be a little bit more of a straightforward, I don't know, quote unquote normal kind of a question. This one's got a little bit of a unique aspect to it in that the top doesn't factor. So this happens once in a while, and you do need to know what to do in that case. So we're going to see what to do in that case in this example. So you will have seen it once, but a lot of the time you'll notice we don't have to do it. It's a little bit easier, and we'll see kind of what that looks like in the next example. But the bottom does factor, so I'm just going to leave the top alone. The bottom does factor. And I believe it is minus 4 plus 1. So we get negative 4x plus 3x, which is the negative x in the middle, and minus 4. And that's it. If you had a degree 3 polynomial on the top or the bottom, then the factoring would be more involved. You would have to do higher degree factoring with factor theorem and synthetic division, and do some of that work too, and probably do 2 lines to get the thing fully factored, right? So however it is that you're factoring, that's what you do at this point. There's no rule that it's always a quadratic. Does that make sense? Okay, then what I always start with is intercepts. And this is what I'm talking about, where you have an order. When you are, if you don't have an order, if you're just kind of doing it randomly, and you have to stop and think for 20 or 30 seconds of, okay, what am I going to do next? Now what do I do? Now what do I do? Again, you're just going to run out of time. But if you have that habit of an order, then you're just, okay, now I do this, now I do this, now I do this. And then the next part of it is, how well do you know how to do each of those things? Like, we're going to find the y-intercept. Do you know how to find the y-intercept, or do you have to stop and think about how to find the y-intercept? If you practice these enough and you just know what to do, then you're bam, 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 bam. You're flying through it, and you can do these sketches much quicker. If you're stopping every time to think, it's going to take you a long time. So how do we find the y-intercept? Or what is the y-intercept, and how did you find it? So there's a fast way of doing this that's easy. That's the method that I would suggest. But the default way of finding the y-intercept is by subbing 0 in for x and just solving, right? You just plug 0 in for x and punch it into your calculator, and you'll get the answer.
Isn't it 2/3?
No, but that's for something else, isn't it? That was...
That's for the horizontal aspect.
Very good. So we'll come back to that when we get to that asymptote.
3/4?
It's 3/4. Because, so normally I wouldn't show this. When I sub in, I'm going to use the top line. 2 times 0 squared minus 3 over 3 times 0 squared minus 0 minus 4. All the x terms are gone because of the 0. They're all being multiplied by 0. And you're left with negative 3 over negative 4, which is 3 over 4. I'm going to write that out as a decimal because that's going to be handy when we go to graph. We like fractions in math class, but when we're graphing, decimals are better because it's easier to determine where they fall on a number line, in particular relative to other things. And similar to what we did in Unit 2, if you get things on the wrong side of each other, specifically an x-intercept on the wrong side of an asymptote, your graph will not work. It won't make sense. You won't be able to graph it. So you're going to lose a mark for getting something wrong, but then you're also going to lose tons more marks because you can't even draw the graph. Okay? So what's the easy way of just getting the y-intercept without having to sub in and show that step? And this is what I'm talking about, is like, if you know this and you can just do it quickly, you save yourself tons of time. Zach?
Would it just be 1? Because what happened to the 1?
What do you mean?
Like on the y-intercept, you did, like you forgot the 1 from x plus 1.
I use that one though, right? Yeah. So what's the trick, Maddie?
I used divide the constant.
Yeah, it's just the constants, right? All this part is gone, and it's just the negative 3 over 4. So you don't have to show any work. What's going on here? Get lost. Okay. You don't have to show any work. You can just pick it right out of the equation of the expanded form. If I was given factored form, I would expand it probably to get the expanded form. If I'm given expanded form, I'm going to factor it to get factored form. So I have them both because they're both useful. Now, x-intercepts. This is where this one is a little bit abnormal, a little bit different from a lot of the other examples that you're going to go through, in that I can't get the x-intercepts directly from the equation. Often you can, and you just state them. But in this case, I can't. So how do I get the x-intercepts?
You use the factor form, and you rearrange for x.
Correct. But there's a bit more to it. What do you mean? Oh, like rearrange this whole thing.
No, the bottom ones.
So not the bottom.
X minus 4 and the x plus 1.
Okay, not the bottom though, not for the x-intercepts. So x-intercepts are where y is equal to 0. When is a fraction equal to 0?
When the top is equal.
Thank you, when the top is equal to 0. Okay, so this is what you're probably going to be thinking of. Top equals 0. If I had factored form, I would use it. This is the part where the top didn't factor. So what do? I just set it equal to 0 and solve. You might even have to use quadratic formula at some point to do this. So you're solving. Like however it is that you solve, you've learned how to solve. That's what you do. We solve by factoring when we can. That's why we factored it. we solve by quadratic formula if we have to. In this case, I'm going to solve by isolating. What do I do next? Whoops.
Square root it.
Take the square root of both sides, and what do I have to remember when I take the square root?
Consider the plus and minus.
Yep, so in this case, we absolutely need the plus minus. And again, I'm going to, on my calculator, figure out what that is. Square root of 3 divided by 2. I want the decimal, so it's approximately 1.2. And 1 decimal place is good enough for sketching, for graphing, so, you know, there's no rules about the rounding or anything like that. That's just for reference so that you know where it is on the number line relative to other things that we're going to have. Okay, and there's 2 of them, there's plus minus. So we've got 2 x-intercepts. That's all the x-intercepts, right? We found all the x-intercepts. You only ever have 1 y-intercept. So now I move on to asymptotes. You're maybe already starting to see how many little bits and pieces of details that we need to know. Like you need to know how to find the y-intercept, and you want to be able to do it quickly. You need to know how to find the x-intercepts, and there might be some different situations where it's not so straightforward, like that example. Now we need to remember how to find vertical asymptotes. From last week, or last lesson, how do you find vertical asymptotes? Katie? Where the bottom equals 0. X-intercepts are where the top is equal to 0. Vertical asymptotes are where the bottom is equal to 0. See all the little things you need to know, and as I keep saying, quickly if possible. So bottom equals 0. So, and I always start with vertical asymptotes. And I always do them left to right. Again, you don't have to. This is my habit. When I go to graph, it helps me. It saves me time because I know that I always do it in the same order. But, you know, it's kind of up to you, I suppose. So I'm going to do, what are the 2 asymptotes?
-1 and 4/3.
Right, -1 and 4/3. So I'm going to do x equals -1 first. Now we have to know how to do the vertical asymptote testing. Do you remember how to do that? That's what we learned in the last lesson as well. How do we do it, Evan?
You choose a number slightly to the left of -1.
Very nice. We pick x values just to the left and just to the right, but very close to the asymptote. And we plug them into the equation and figure out if we get a positive or a negative. So what would that number be? Yep, no. So f at -0.99, is that just to the left or just to the right? Now remember, the negatives are are backwards, so sometimes people get that wrong, and if you get it wrong and you pick the number to the right, but you thought it was to the left, again, things are going to kind of fall apart. So
1.01, -1.01 would be left, and then
okay, so -1.01 and then -0.99 would be to the right. Good. So again, I'm going to do them in order, but you don't have to. It's up to you. I'll point out when we get there why doing them in order is kind of helpful, but it's not necessary. Now, the other thing about this one that's a bit tricky, because that top didn't factor, is the testing part is maybe a little bit harder. So I'm going to walk you through some different strategies. It's going to be your job to figure out which strategy you like, which one makes sense, and which one to use to be most efficient in which circumstances. So for example, in this case, because the top didn't factor, it might be easiest to just put it into your calculator. And if I was going to do that, I would go like this, 2x squared minus 3 over 3, and you could use either form, right? Expanded form or factored form, I guess whichever you think is quicker to type. So 3x squared minus x minus 4 and hit equals, and that number is irrelevant. And then I would start plugging in the numbers and doing the testing, right? That doesn't take very long to do that once you know how to do it. But if you're good with numbers, and if what I'm about to go through makes sense to you, you could still do the inspection in this case. When I square, where did it go? So I'm going to look at negative 1.01 first. When I square it, I'm going to get a number just bigger than 1. Not a lot bigger than 1, right? 1.01 squared 1.02, right? So it's very close to 1. When I multiply that by 2, I'm going to get a number very close to 2, and when I subtract 3, it's going to be negative. So the top will be negative. 1.01, negative 1.01 times 3 is negative, minus 4 is still negative, and negative 1.01 plus 1 is just barely negative. So that's negative, and that's negative. So 3 negatives means the whole thing, the whole product will be negative. Remember when we did this before? But notice how that's a little bit messier with the top because it's not factored. So it's up to you. You have to decide which method you, but I want you to understand, you can always fall back on just putting it in your calculator. But if you can do the inspection, it's faster. Let's see what it would be on the calculator. Negative 1.01, shift store that. Did I hit that right? No, I didn't. Shift store in X. Go back up and hit equals. And I got negative 13.7. But I only care that it's negative. When I put negative 0.99 in, again, I'm going to get negative on top. Squaring 0.99 is still going to be less than 1. So times 2 is going to be a little bit less than 2. Minus 3 is going to be negative. Minus 4 is negative. Plus 1 is just barely positive. So 2 negatives makes a positive. There's so much to this. Whenever I teach it, I worry that students start getting sort of lost and start like, okay, Mr. Bellaire's saying a lot of stuff, but I don't know where any of these numbers and negatives and this and that are coming from. And if you feel that way, all I can say is at some point you got to ask or go back and look through it again or figure it out, right? Like you're supposed to be able to follow and understand what I'm saying, in other words. So if you don't, make a note and ask about it later, right? And I can go over it more slowly or we can just talk about it again. Yep.
I thought that the vertical asymptotes were like at the same point as the x-intercepts.
That's of a reciprocal graph. This is not a reciprocal graph.
Okay.
But if you think about it, it's the same idea because it's like the x-intercepts of the bottom. If I thought of that as a parabola, those would be the x-intercepts. Right? So the asymptotes are at the x-intercepts of that function. That's in the denominator of the total function. So it's related, but yeah, that's when we do reciprocal graphs. Okay, so I've got those. I'm going to write out the summary here. As x approaches negative 1 from the left, y is going to?
More negative.
Yeah, and so we call it negative infinity, right? So negative, but negative infinity. Good. As x approaches negative 1 from the right, y is going to? Positive infinity. Okay, next vertical asymptote. Oh boy, this one's tricky too because even just having a fraction, because we have to pick numbers just to the left and just to the right of this fraction, that can be hard for some people. All this hard stuff that we do, and it's always fractions that makes it even harder, right? Is almost the hardest part for some people, which is too bad. So 4 over 3 is 1.33 ... continuously. So what would be, at least it's positive, that makes it easier. What would be a number just to the left and then just to the right of that?
1.32 and 1.34.
Good, 1.32 and 1.34, those would work fine. You don't have to pick the same numbers I pick. I'm just going to point something out here though. What about 1.33? If I just truncate the 3's, that makes it smaller as well, right? So you could do that, but if you're not comfortable with that, use 1.32, that'd be fine, it makes no difference. Okay? And 1.34. And again, when I put them in, again, this one might be tricky because of that. Like, what is 1.33 squared times 2? I don't know, is that bigger or smaller than 2? That's hard to tell, isn't it? So again, you might end up just punching this into your calculator. And there's nothing wrong with that. I always say there are things that we can do to save time, but if in some cases they don't save you time, then don't do them. And if you sit there staring, trying to figure out for too long whether the top would be positive or negative, you would have saved more time putting in your calculator anyway. So why not just do that? So that's what I did in this case as another example of different things that you can do. And I got those two values, and those are rounded. So if you put that into your calculator, I don't think you'll get that exactly. And that means as x approaches 4/3 from the left, y is going to negative infinity. As x approaches 4/3 from the right, y goes to positive infinity. People love to make up their own little rules or patterns, like if one's going up, the other's going down. If one's going to positive infinity, the other one's going to negative infinity. That's not a thing, okay? Or like the first one's always negative, the second one's always positive. Nope. They can do anything. We looked at graphs the other day of that. The top two graphs are functions that are both going up or both going down from the left and the right. So it's not always one or the other. Okay, it can be both the same. So you have to do the full testing and make sure. There's no shortcuts. Okay, there were two vertical asymptotes, and we found them both, and we did the testing. So now, what's next? The horizontal asymptote? And how do we find that? Sure. 2/3. So the degrees are equal. So we use the coefficients of those terms that have the biggest degree. So it's y equals 2/3. Please make sure to write them. Whoops. So horizontal asymptote, y equals 2/3. Again, as I've said, because these questions are so long and there's so much to them, it's important that you think about how you're organizing your work. Okay? I'm just going to move that down a tad. Okay, how do we do the testing for the horizontal asymptotes? It is different in a very important way from vertical asymptotes.
Is it like positive 100 and negative 100?
Yeah, we use a big negative number and a big positive number. Whether you use 100 or 1,000 is up to you. I've used 1,000 often in the past. Some of my old notes I have 1,000, but 100 works too. And for this one, this is what's really important. You have to put it into the calculator. There is no testing, like inspection for this one. Sorry, there's testing, but the testing is, it has to go in the calculator. So negative 100, and because I already programmed the function in, that makes it easy. So this is where I'm encouraging you to decide what's the most efficient method for you. Yep.
If it's like a little bit off, is it fine? Because I got 0.6688 instead of
You got 0.6688. That's because you put in positive 100, and that is not okay. That's a very different answer. In lots of cases, it's probably fine. If you used 1,000, your answer would be a little bit different from mine. But the one that you got would actually be wrong in this case. See, 0.6688 or 0.6689, I suppose, if you round. And finally, the last thing we need to know how to do, we needed to know how to find the horizontal asymptote. We needed to know how to do the testing, what numbers to put in. Now we have to know how to interpret that output. So what does that mean? Again, just because this is a fraction makes it a little bit trickier and it might not be as obvious.
You need to say whether that's above or below.
So I'm comparing this to the horizontal asymptote and determining whether it's telling us the function is above or below the asymptote. The horizontal asymptote 2 over 3 is 0.66 dot dot dot, right? So is that above or below? Here, let me do this even, 6. It's below. And then 0.6689 is above, right? So, Amar, when you were asking that before, if you had 8 there, you would have said it was above, which would be wrong, right? So it would have messed stuff up. So in some cases, it's going to matter. In some, if you're off by a decimal, it won't. So as x goes to negative infinity, y approaches 2 over 3, the horizontal asymptote from below. As x goes to positive infinity, y approaches 2 over 3 from above. You don't have to also write above and below, but any questions? So that took us like 25 minutes, and that we haven't even sketched it yet. That's just the pre-work. This is what I mean. There's a lot of things. And now I have to go back into all of that information and pull out the pieces that I need sort of one at a time and start putting them together to make the sketch. So the better organized this is, the easier that's going to be. Any questions before we start sketching? Okay. You will be drawing your own axes for these because the questions are so big and some people write big and some people write small. I can't predict where on the page to put it for you. So you're going to be drawing your own. So, when it's for an assessment, you make sure that you're using a ruler and that you're labeling everything.
Lose a mark if we forgot to add the little y and x there?
It would maybe be a half mark for forms. They need to be there, yes. And if you did that multiple times on a test, I don't think it would take off marks every single time. But in the whole test, yeah, you would lose a mark for that. It's got to be there. Exactly how you start now is going to maybe depend on the person, depend on the situation. I don't have a specific order. What I do is I look at the vertical asymptotes and the x-intercepts and start just thinking about where they are relative to each other and how far apart they are, like how big the numbers are, and sort of trying to hopefully make an educated guess at how to space things out so things aren't too spread out but also not too tight together. So I have an x-intercept of negative 1.2 and an asymptote of negative 1. So those are the two negative ones, and negative 1.2 is further to the left. Okay, so I'll put this one sort of out here. And then the vertical asymptote has to be inside of that one. Because negative 1 is further to the right of negative 1.2. Does that make sense? Whoops. On the other side, I've got another x-intercept of positive 1.2. So I'm going to try to make it about the same distance away. And then the vertical asymptote on that side, and you don't always have two vertical asymptotes. You could have as many as possible. Like you could have 10, but most of the questions we do will have one or two. Sometimes only have one, so it's not like you always have one on one side and one on the other. But anyway, in this case, it's 4 over 3, which is 1.3. So the vertical asymptote is on the other side again. If I had, and you're going to see why when we start to graph it, if I had the x-intercept on the wrong side of the asymptote, my graph isn't going to work. If my horizontal asymptote is on the wrong side of the x-axis, like if I've got it as a negative and it's supposed to be positive or vice versa, your graph's not going to work. Okay, so our horizontal asymptote is positive. It's y equals 2 over 3. Whoops. My y-intercept is 3 over 4, so that's above the axis, somewhere up here. That's not as big a deal. That's, if I get that wrong and it's below, then it's not going to be the end of the world. You're still going to be able to graph it. But I'm making a mental note that it's above. 3 over 4 is 0.75. 2 over 3 is 0.66. So the y-intercept is above. I'm not going to plot it yet. I'm going to draw a smooth curve and just put it wherever my curve goes through the y-axis. But again, that's up to you. Okay? That's just often the way I do it. The x-intercepts you kind of need as like anchors of where your function is going, but the y-intercept is not so important. Everybody good with all that so far? Okay, final thing I'm going to do is pencil in my end behaviors. And this is where it pays off that I've done stuff in order. Because I'm not even really looking at those numbers. I'm just looking right there because I know I started with the leftmost asymptote, and I know I started with the number that's to the left of it. So to the left of it, we're going down, and to the right of it, we're going up. So when I said before I do it in order for a reason, that's the only reason. Is because then when I go to read them, and these questions are long enough as it is, it's kind of useful just to, quickly glance at it and see, okay, we're going down first when I'm left and up when I'm right. And the other one, again, as we're approaching from the left, we're going down. As we're approaching from the right, we're going up. And finally, for the horizontal asymptote, to the left, we're below, and to the right, we're above. So to the left, we're below, and to the right, we're above. So, again, all the stuff that we've done, finding the asymptotes, doing the testing, understanding what the testing means, like, interpreting the testing, and just how to write it with the notation and everything. And then how to take all that and behavior and testing and put it on the graph. You need to know how to do that too. What does it mean that it's approaching from below or from above? What does it mean that to the left it's going to positive or negative infinity or whatever? Okay? And now that we've done all that, I can finally draw the actual function. Now I'm just putting all these pieces together as I draw it. Okay? So I've put the properties on the graph. Now I have to actually graph it. And this is where, if you've done something wrong, it won't work. So for example, if this is on the wrong side of the asymptote, how can I get from there to there? You have to cross the x-axis, don't you? This graph, is going to go like this. I'm going to draw that better in a minute. But generally speaking, that's what it's going to do. It has to cross the x-axis to get up to that end behavior. So if there wasn't an x-intercept there, it wouldn't work. So the pieces have to fit. Okay, so here I go. Smooth curve as much as possible. No hard turns or corners or straight lines or anything like that. It should be curving. It should be approaching the asymptotes. It doesn't curve back in or anything like that. You may think this is picky, but if it goes over the asymptote even a little bit and then you bring it back and try to fix it, like that's not enough. You need to erase that and redo it. I would say if you do your asymptotes in a different color like I do, that probably means you're using a pen, which is dangerous because if you need to fix it, that's hard. But the graph itself, I would really say use a pencil or get pens that are erasable. They have really good pens that you can erase nowadays, right? So make sure that you can erase it. This part over here is easy. I'm just connecting those two end behaviors. Okay? You don't have to erase those little arrows. You can just draw over top of them depending on how you do it. And this is the part that really kind of makes everything click to me, is this middle part. Look at how everything makes sense. I'm starting up here and I'm ending down here. And I have to go through the y-axis there and the x-axis there. So doesn't that work?
But it's going through the line and the horizontal aspect.
Yeah, that's fine. It's allowed to. Okay, so all those pieces fit. If my y-intercept was negative, I wouldn't have been able to draw this graph this way. Because you can't, get rid of all this stuff. You can't go down here and then come back up and do that because you've just drawn new x-intercepts that we didn't find before. That never happens. Those are called phantom x-intercepts, I call them. And they're like, you are trying to make properties mesh together, but you invented new x-intercepts. Wrong, wrong, wrong. And this is really wrong. So you end up losing lots of marks. Okay? So if your graph isn't coming together in a straightforward way that makes sense, you probably have calculated something wrong. Yep.
Sometimes you'll start like above the asymptote, then it'll cross it, and then it has to approach from the bottom, so go underneath and then.
We'll see an example of that, so let's talk about it when it happens. Okay? Okay, so I'm going to draw it nicely now. So I'm coming down. Remember, my y-intercept was above the asymptote, and I made a note of that to myself before, so. And now I'm going to draw it in and label it. Yes?
So if an asymptote is a line in which the function approaches but never touches, how can it go through?
So this is an asymptote to the right of the graph, but not necessarily for the entire function. Not every part of the function approaches it, just that part.
Okay.
But,
Also, you accidentally erased the 1 point.
oh, thank you.
Point 2.
But it's a really good point that you bring up because it is a rule that you cannot cross a vertical asymptote. Because a vertical asymptote is where you're dividing by 0. So how could you not divide by 0 in one place, but divide by 0 in another place? Like that's not a thing. But horizontal asymptotes can be crossed because they're only horizontal, they're only asymptotic for large positive and negative values of x. So other values of x, they can cross that asymptote. And I'm just going to double check that I've labeled everything. And my asymptotes, all of them, the vertical and horizontal, and all of my intercepts and everything, and it looks like I'm good. Any questions? Okay, we're going to do one more. This one will be a little bit faster because it's a little bit less messy. And also because now that we've done one, we'll go through this one a little bit more quickly. Remember, if there's things that I'm saying that you don't understand, where does that number come from? Where is he getting this stuff? Like, at some point, you're going to have to ask for clarification. If nobody's asking, I'm assuming you understand. And what you shouldn't assume is if you can't answer these questions now, Why would you be able to when a test comes? Unless you practice and figure it out. So when I say, what do we do next? And you're not sure, right? But then when I tell us what to do, you go, okay, that makes sense. Okay, but hold on, you didn't know what to do. So you got to go practice more to make sure that you're the one that knows what to do, and you're not just following and understanding what I'm saying. So first thing that we're going to do, what is it?
Intercepts?
No, before we do that,
Factoring.
good, thank you, factor. So the top obviously isn't factorable because it's linear, but the bottom is x plus 4, x plus 3. Simple trinomial, easy factor. It's fully factored. Now we go to intercepts. Yep.
For that, do you have to like show your work, or can you just like?
Gosh, no. If you were doing synthetic division or something, you would probably do that on scrap paper. Like, no. Often it's just going to be one step anyway. Once in a while you might have to use like factor theorem, but often it works out in such a way where it's a fairly simple factor. Okay, so I always start with the y-intercept. The y-intercept is 1 over 6, so 2 over 12, which reduces to 1 over 6, right? Again, you certainly don't have to show this. You just write 1 over 6. And 1 over 6 is 0.17 approximately. X-intercept. So again, this is where like if you're not sure how to find the x-intercept, I mean you haven't practiced yet, so I wouldn't be surprised if you're not nailing it. But you need to know this, and the faster you know it, the better off you're going to be. And if you just know what to, okay, y-intercept, then x-intercept, and I get it from here, and I know this, and then I do asymptotes, and you're just bam, 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 bam. Otherwise, it takes so long. Amara?
It's -2.
Why?
Because was it like the top equals 0, so if you do x plus 2 equals 0, you just rearrange it.
It's -2 because it's where the top is equal to 0. And since the top now is factored, I just pull it right out of there. I don't have to set it equal to 0 and show that work. The whole point of having it factored is because I can pull those solutions easily. That's it. There's only one x-intercept this time, right? So asymptotes. I always do the vertical asymptotes first. What are the vertical asymptotes? Zach? -4, -3, and you get those from where the bottom is equal to 0. See how there's all these little bits and pieces, and as you're going through it, the more you have to stop and think, it just slows you right down. But if you know it, you kind of start flying through these. So I'm going to do the x equals -4 first. And now we have to know how to do the testing. A number to the left of -4 and to the right of -4, but very close to -4. Yep.
-4.01 and -3.99.
And -4.01 is just to the left. Again, like I said, I always do them in order. And this one is perfectly set up for that inspection. -4.01 plus 2 is negative. Plus 3 is negative. Plus 4 is just barely negative. Right? So negative. -3.99 plus 2 is negative. Plus 3 is negative. Plus 4 is now just barely positive. So 2 negatives makes positive. If you don't do them in the same order every time, I guess you'd always have to be kind of looking back to see, wait, which one was this? Was it negative or positive? Even when you're writing out these notations. So again, because I always do them in the same order, it's just, I don't have to do that. I don't know how much time that saves really, but I feel like it makes it easier for me. Okay. The next asymptote was x equals -3. So f at -3 -3.01 and F at -2.99, similar to the first ones. And in this case, -3.01 is going to be negative, positive, negative. So 2 negatives, which is positive. And -2.99 gives us just 1 negative, the x plus 2 on top. The two bottoms are both positive. So 1 negative means overall it's negative. Once again, folks, if you're not following that inspection that I'm doing, you can plug them into your calculator. You can always fall back on that. You need to know what strategy you're using, what technique you're using, what works best for you. Okay, so as x approaches -3 from the left, y is going to positive infinity. Notice that these flipped. So the other ones that we did, even in the first example, were all kind of the same, but this last one that we just did is different. And once again, they can do anything. There's no rules or patterns, so you have to go through the whole testing. What's next? Horizontal asymptote. And what is it? Noor? Y equals 0. How come?
Because there's an x squared at the bottom.
Because the bottom has a higher degree. It's x squared on the bottom, so it's like 0x squared over 1x squared kind of thing. But you know, it's always, if the degree on top is lower, it's always y equals 0. Horizontal testing is different from vertical testing. Good. Big numbers, positive and negative, and these ones have to go into your calculator. Some people have been having problems with their calculator, saying they can't get the right answers. If you have a fraction button, you probably want to use that. Otherwise, you need brackets. Okay? So bracket -100 plus 2 bracket divided by bracket, I'm actually using 2 brackets here. -100 plus 4, bracket, -100 plus 3. Again, I'm going to keep saying this because it's such a common mistake. People get to the test and they say equals negative. But that's not what we care about. That's wrong. We need the number to compare it to the asymptote. Because the asymptote is 0, in this case, that happens to work, but that's not what you write. You write -0.01. Okay, and when I punch the next one into my calculator, it's positive 0.01. And how do I interpret that? Evan?
As it goes to -infinity, it's less than 0.
It's approaching from below. It's below 0. It's less than 0, right? Okay, so I'm comparing it to the asymptote and deciding if it's above or below. Whoops. As x goes to -infinity, y approaches 0 from below. As x goes to positive infinity, y approaches 0 from above. There's all the pre-work. Now we can start putting it all into the graph. Yep.
This is what I get, which makes sense if I round it, but would it make a difference if I put that number instead?
No. Once again, whether you start with the asymptotes or the intercepts doesn't really matter. You're probably thinking about all of them and sort of realizing that we've got 2 asymptotes that are both negative, -4, -3, and then an intercept that's also negative, -2. Okay, so So I need to kind of just take that into consideration and line them up. So I'll put -4 over here. And then I'm actually going to put my intercept about halfway. And then the other asymptote about halfway between them. It's going to make my asymptotes a little crunched, but again, I don't want to make my graph too big because it's harder to draw the nice curves that way and that sort of thing. I only have the one x-intercept, so that's that. The horizontal asymptote is at 0. A little bit tricky to draw because it's right on the axis, but like to make it show up, I mean. The y-intercept is small, but it's positive. So that's kind of what I need to know.
On the test, can we just like write beside like y equals 0, or do you want to see that we like tried to show like the?
You should probably draw it in, yeah.
Okay.
Especially if you're using pen, it can show up. I'm not going to be too picky about that, but. Okay, so behaviors. For the first one, from the left, I'm going down first, then up. So down from the left, up to the right. Second one, from the left is up, and from the right is down. So notice how this is going to make a different graph from the last one. And all I can say is there are so many different kinds of graphs. We're not doing every type. So there will be different ones in the homework that we haven't seen before. And you're like, oh, I didn't know they could do that. Which is the whole point of the practice, is that you're seeing more different kinds of these graphs and different things that they can do. Okay, to the left, we're below the asymptote, and to the right, we're above the asymptote. So to the right, I'm above. To the left, I'm below. And now I can start putting the pieces of the graph together. Everybody good? Okay, well, I shouldn't have erased those maybe just yet. So I'm just linking up these two, and that part is fairly easy. So I'm going to start with that. So it just comes from here and goes down. Remember the last example? Started up here and went through and ended down there. But this one doesn't do that. It just links those two. Some people are like, oh, it's a parabola. I mean, it's not a parabola because it doesn't follow that, but it kind of looks like that. And the common question here, yep, go ahead.
I was gonna ask, how do you know how far down?
That's what I was just about to say. The common question here is, how do you know where to turn? So you take calculus, and you'll learn how to calculate that point. If you have x-intercepts, then it would have to cross and cross, possibly. What if it had only one x-intercept?
Then like the point of it would be perfect.
The turning point would be on the axis, right? Otherwise, it doesn't matter. So you turn it wherever you want. This doesn't look very good to me, just doing a little dinky thing like that. But again, I don't know that that's about losing marks or whatever. So it doesn't, in the end, exactly matter where it turns, okay? And finally, this last part is really interesting because the pieces connect. I start down here, I have to cross, or I guess it could turn on the x-axis, but in this case, we're crossing it because I have to get up to the y-intercept, which is positive, and I have to approach from above. So doesn't all of that kind of fit together and make sense that I'm going to come up like this and then sort of turn and do that. And remember, I didn't mark this before, so I'm marking it now, labeling it. And again, people might say, how do you know if it turns sort of before or after the y-intercept? You don't know, so we would just leave it for now. In calculus, you would learn how to find that point, but we don't know how to find it, so it doesn't matter. Make it nice and smooth and try to make it as natural as you can, kind of thing. I'm not going to be, I've said this in the past, super picky on what your graph looks like, but you should be doing the practice to get used to what these things look like and how to draw curves that make sense. And there are certainly occasions that if you make a graph do something that they don't do, you will lose marks. Okay, like crossing asymptotes or not being a function or just looking really weird, then you can lose marks just for kind of not graphing carefully. But for the most part, I know people aren't great at art or whatever, great artists, and it can be tricky to draw these. The other thing I always say is start getting used to using graphing software after you're done. I mean, you could look at my solutions online, but maybe it's even better to graph it with technology, and the technology will show you what it really looks like. You know what I mean? Because mine's probably pretty close, but that's going to be better. And so then you can start to get a sense of what they actually look like, and you can try to make yours look similar.
So like, I know like that's an asymptote there, and that's how we like bring it closer, but like before we just like cross through it, why can't we just like keep going?
Because that's not what this function does, right? So that's when we do the behavior, there are other functions that can have asymptotes going one direction and can just have like polynomial type end behavior where it just goes off into a quadrant. But these functions don't. These functions, rational functions, always have either, or for us at least, an oblique asymptote or a horizontal asymptote going in both directions. So, you know, we did the testing around the asymptote. We determined that it's approaching from above. So that's what this function does. You would need a different type of function, not a rational function, to get that kind of an end behavior. Any questions?